Hi, this instructional video will walk you through the installation procedure of a LCP, Local Convergence Point closure. LCP closure is where our first level splitter is housed. This is where the feeder cable is branched out to distribution cable. The fiber closure that we will be using on this video is a Huawei product with model SSC2101HM, which is a dome-style heat-shrink sealing closure. It is typically used by both Globe Telecom and PLDT's FTTH projects. The LCP enclosure location is along the 144 core feeder path in either aerial or underground fed. The feeder cable is spliced through the LCP enclosure and take cores out from the 144 and spliced to the level 1 splitter pigtail, which is in our example, a 1:4 splitter. The output fibers from the PLC splitter will then be spliced to the 72 core distribution cable. To start, we will open up the end port using a hacksaw or a blade cutter. Open straight through port closure end cap. Open drop cable port end cap. Using the blade cutter, carefully smooth off the edges. When using sharp objects, always exercise caution. Scratch or rub the port surface with sanding paper to make the surface rough. The rough surface will help the shrinkable tube attachment better and stick firmly. Strip the feeder cable sheet from the loop 2 meters for mid-span openings. Wrap an insulating tape at the cable sheet ends. Put aluminum foil provided around the cable to where the heat shrink will be located. This foil serves as a protection to the cable when heat is applied later to seal the port. Insert shrinkable tube to the cable. Insert buffer loop to the straight-through cable port. Attach the strengthening member to the cable retention plate. Tighten screws to secure cables and strengthening member in place. Retain a strengthening member allowance 1 inch from the end of the sheet so that the buffer tube won't get stressed. Trim excess strengthening member. Cable opening for splicing shall be limited to 1 meter for end cable opening of the distribution cable. Put the shrinkable tube first before inserting the strip branching 72 core cable onto the drop port. This closure has 5 drop port out. It has 144 core splicing capacity. Do the same for the branching cable. Attach the strengthening member to the cable retention plate. Tighten screws to secure cables and strengthening members in place. Place shrinkable tubes onto the ports. Put separator in between the straight-through cable. Start heating the shrinkable tubes using blue torch. Don't move the torch closely or directly to the shrinkable tube, as it might burn the tube completely. The shrinkable tube should be smooth from heating and follows the shape of the cable port. Make sure that the heat sealing gel comes out from the shrinkable tube to ensure sealing integrity. Separate orange buffer tube from the main or feeder cable. According to Globe Telecom's guideline and practice, fiber core number 13 to 24 is assigned for LCPs, which is the orange buffer tube, while fiber core 1 to 12, 25 to 72 is assigned for naps, which are the rest of buffer tubes. Pass-through loose tube shall be stored on the closure cable rack. Separate blue buffer tube from distribution cable. This buffer is for the nap. Loop remaining buffer tubes at the back of splicing tray storage. Secure with cable ties. Cut excess tie wraps. Strip buffer tube blue. This buffer comes from the 72 core distribution cable. Strip orange buffer tube using a fiber cable sliter. This buffer comes from the 144 core feeder cable. Carefully take fiber 13 out from the buffer, and idle unspliced fibers shall not be cut and shall be stored in the splice tray. Insert buffer tube hose to the orange buffer tube from the 144 core feeder cable. Insert buffer tube hose to the blue buffer tube from the 72 core distribution cable. Secure buffer tube with tie wraps. Use black tie wraps to indicate feeder cable buffer location and white tie wraps for the distribution cable. Groom excess fiber to the splicing tray loop holder. Place 1:4 PLC splitter on its assigned tray. Separate splitter out pigtails from its attachment to the other fiber cores so that it will easily get spliced to the distribution cable. Strip fiber 13 of the feeder cable. Fiber 13 is the fiber color blue of the buffer orange. Clean the bare fiber with cotton or tissue and alcohol. Cut excess fiber core 10 mm from the fiber tube using a fiber cleaver. Set the cleaved fiber to the splicing machine. Insert splice sleeve to the splitter pigtail. Strip the tube and remove covering. Clean the bare fiber with tissue and alcohol. Cut excess fiber core 10 mm from the fiber tube using a fiber cleaver. Set the pigtail core to the splicing machine. Operate and initiate fiber jointing to the splicing machine. Acceptable splicing loss is -0.05 dB maximum. Move splice sleeve onto the splicing point. Put the splice point with sleeve onto the splicing machine oven. This is to shrink in the splice sleeve material to the bare fiber. The red light indicator turns off once the splice sleeve shrinking is complete. Do the same process of jointing to 4 core pigtails out from the splitter and the fiber numbers 1 to 4 of the distribution cable. Insert splice sleeves to the 4 splitter pigtails and splice. Place splice fiber with sleeves to the tray. When grooming the loop, make sure to follow the loop diameter of the splicing tray provided to avoid micro bend loss. Put the tray cover in place. Secure splice trays to base with provided Velcro straps. Position and limit fiber counts in their proper splice tray as seen on the table, tray 1 being the bottom tray. If the scenario is aerial, mount the LCP closure on the pole with 2 stainless straps and a loop holder provision below the closure. Provide a 15-meter loop on each LCP location. Apply maximum 400 mm diameters of cable loops. Flash test dome closure with pressure 5.8 psi or 40 kPa to ensure that it can withstand water immersion. Physical test and inspection is also implemented upon project acceptance. This ends our video tutorial. I hope you enjoyed and learned. Thank you for watching.